Hi, my name is Josh and I work with Affinity Energy, and today we're going to be talking about another I&C short tip. Specifically, we'll be talking about powering devices using solar modules and batteries. The three factors to consider when you are designing a system like this are the location, the power consumption of the devices, and the battery, the solar module, and charge controller. So the first factor we want to talk about is the location of your device. So hopefully you're going to be outside because you need the sun. And so we've got here, it's a rough drawing of the United States. And the sun sets over here, which is the west, and rises in the east. So you really want your panel, say this is your solar panel right here, to be facing south at 45 degrees for max sun, because the sun is going to rise this way and set over here. The other thing to consider is in your location, are there any trees or other shading sources like a utility pole, with like a transformer or something on it? Shading on the panel will prevent the battery from charging because the solar module won't be producing the power it should be. So the next factor to consider is the power consumption of the devices you are going to be using. So for an example, we are going to use an Atom module, a Redline, and a Sierra Wireless RV50 cell modem. Find the data sheets for those devices and look for the paragraph that contains the power consumption. So if you add up all of these numbers, you should get 27.7 watts of total load. The third factor for our design that we need to consider is the battery, the solar module, and the charge controller. So you can see up here I've got a rudimentary drawing. So this is the charge controller here, and then the load, this is what we calculated before, is the load of our devices here, and then you've got a battery connection here, and then the solar panel connects here. So this is pretty typical of all charge controllers. So for our application, we've got 24 volt load, 24 volt DC load. And so the battery needs to be a 24 volt battery. So that can either be, most likely it's probably going to be two 12 volts. So for our design, we're going to look at lead acid gel and AGM technologies. And these are good because they don't require any maintenance. They can be mounted upside down because there's no free acid within the battery, and they can be deep cycled so that if there's rain or clouds for many days, or if there's an eclipse of the sun, then it should be able to handle it depending on the amp hour rating of your battery. So the next thing we're going to look at is the solar module. So we've got one right here, and this one is rated for 20 watts. So you can tell right away that this is not powerful enough to power the 27.7 watt load that we've got. So you need to look at something a little more powerful, and you want a little buffer between our 27.7 watts. We might spec something like a 40 watt panel as long as the voltage matches. The last part of our system is the charge controller, and this is what ties our system together. So the charge controller is going to have, like we talked about earlier, a solar input, a battery input, and a load. So the charge from the panel is going to come in, and the charge controller should be rated, for our system it'll be a 12 or 24 volts DC, with probably a discharge current of 5 amps. So the charge is going to come in, and the charge controller will have a rated input, voltage input range, and a current input, which this electrical parameters from your panel will need to fit within those parameters. So the solar is going to charge the battery, and then the charge controller will regulate the voltage and current coming out to your devices. It's a good idea to put a fuse between that just in case you have some large amount of discharge current for some reason, or a short or whatever. And that really ties our system together. So this is not the exact example that we were showing on the board, but this is another example of a system we designed. In this enclosure, we've got a charge controller and battery, but they're combined into one. And then over here, we've got our solar panel. And this is kind of a mobile system that we can set up anywhere as long as we've got sunlight, and it will power these devices. And we can leave it for weeks on end. The battery is a 12-volt battery because our devices are 12 volt. And so the output from the charge controller is 12 volts. And the input is from this solar panel here. And we've got the input coming through a fuse and then going into the charge controller. And it's rated for 15 to 40 volts DC at 3.6 amps DC typical current. Those are specifically the solar inputs. And so our panel is rated for 17.8 volts DC at, I think it's 2.8 amps. So that fits within our specifications. I hope you've enjoyed this video and you've learned a lot about powering devices remotely using solar. If you have any more questions, please contact us here at Infinity Energy, and we would love to help you out.